Hi, today I'll be coding something based on this animation where we have a bunch of arms wrapping themselves around the sphere, and each of these arms is made up of hollow hexagons. That's what we'll be starting from, the number of arms and the number of hexagons, which we'll be setting to be more than what we actually want them to be in the final version, because we don't want to risk a browser crash along the way. So we're going to have 6 arms and let's say 10 hexagons per arm. We're going to then compute the total number of hexagons, which is going to be the number of arms times the number of hexagons per arm. Everything is going to be within the body. Here we're going to have a loop, so while n gets decremented and is still positive, we create our hex elements. Next, we're going to move on to the CSS to put something on the screen, and we're going to start with the circumradius of the hexagon. So the circumradius of a polygon is the radius of this circle on which all the vertices of the polygon are situated. As you can see here, all the vertices of this hexagon are situated on this red circle. So the radius of this circle is what we'll first set. R is going to be 2m, for example, and our hex elements, they're going to get a padding equal to that radius and a background, because otherwise we won't be seeing anything. Yeah, seeing something doesn't really help here because it looks really ugly, but we'll soon change that. We're going to set a grid layout on the body, and here for the hex elements we'll be setting place self center. Okay, better, but not that great, because we have a lot of squares here, but we can't see where one ends and the next one begins. And what we actually want them to be is stacked one on top of the other, all within the same cell. So our grid is basically going to be a one-cell grid. All the hexagons are going to be in the grid area defined by the intersection between the first row and first column. Okay, so grid area, first row, first column. Now, this only looks in the middle horizontally, even though place self should handle both directions, both the horizontal and the vertical direction. That's because at this point the body still takes the height of its content, which is the stack of hexagons. So to fix that, we need to set a height or min height to the full viewport height. Okay, that gives us an ugly scroll bar, which is caused by the margin, so zeroing the margin should do it, but otherwise we can just go full nuclear and set overflow hidden. Next up, let's turn that ugly square into a hollow hexagon, and we'll be doing that with a clip path according to this article that I wrote over 6 years ago and recently updated because there was a need for that, and also prettified some of the demos, including this one, which shows how the clipping path is drawn. So first point, second, third, fourth coincides with the first, then we have the fifth point, sixth, seventh, eighth coinciding with the fifth. So basically we have an outer polygon connected to an inner one and a zero width tunnel between the two polygons. So you can see here how the tunnel grows from 0 to something visible. Okay, and one more thing to note here is that the outer polygon goes anti-clockwise and the inner one goes clockwise, so they go in opposite directions. Okay, that's what we'll be doing here. We'll be having a mixin that creates our hollow polygon. So mixin hollow, we're going to have the number of vertices, which is going to default to 6. We're going to have a border width, 6 pixels, let's say, and we're going to have an offset angle, let's say minus 90 degrees, and I'll explain why minus 90 in a moment. But before that, let's just include hollow. Okay, now I said I'm going to explain why minus 90 degrees. So here, as you can see, we have a polygon, and here we have directly hexagon, but this works for any kind of polygon. So if we have a pentagon, you can see that we start from here, from 3 o'clock, and then we go clockwise, right? And we draw our polygon. And it's the same thing for a hexagon. You can see how we have the first point, second point at 60 degrees, third 120, fourth 180, fifth 240, and the last one at 300. Okay, but if we don't want to start from 3 o'clock and we want to start from 12 o'clock, then we need to rotate 90 degrees. So that's 90-degree difference, and we need to go anti-clockwise. So the positive direction is clockwise, but we're going to in negative direction, right? So that's going to be minus 90 degrees. So that offset angle is there to help us start from 12 o'clock instead of 3 o'clock. Okay, next step is going to be compute the base angle. And the base angle is the angle between two radii, so like this one and this one, and these radii connect the center of the circle with two consecutive vertices. So that's the base angle. In this case, it's going to be 60 degrees. But computed, it's always like this, the base angle, 360 degrees over the number of vertices, which is equal to the number of edges. Next, we're going to have an outer list of points, and we're going to have a loop. So for I from 0 through n, okay, we're going to have that the current angle is the offset angle plus I, the current index, times the base angle. And the outer list of points is going to be its previous version, to which we're going to add the coordinates of the current point. Now the coordinates of the current point are going to be given by the coordinates of the center of the circle, which are going to be 50%, 50%, because it's in the middle. So that's 0%, 0%, and that's 100%, 100%, that bottom right corner, and in the middle is going to be 50%, 50%, right? And that's going to be the coordinates of the middle. And then we're going to have the radius, which is 50% in this case, times cosine of the current angle. Now, cosine trigonometric function, for that I used compass in the past. But now I discovered that SAS has a math module, and that's what we'll be using. So, use SAS math. Okay. Cosine of the current angle. And one thing to notice here is we can take out that 50%, right? And here we'll be having just 1. Put everything within parentheses, right? And then just copy paste this. And for the other direction, for the y direction, we're going to have sine there. And finally, here we're going to have clip path, polygon, the outer points. This should give us the outer hexagon, okay? And then we're going to do the same for the inner one. But for the inner one, we're going to need to get that radial difference. So you can see that we have an outer polygon and an inner one, and each of these is going to have its own circumradius. And the centers of those two circles, those two circumcircles, is going to be the same. So if we draw a radius to the outer one and a radius to the inner one, the outer to the outer vertex and a radius to the inner vertex, the difference between them is going to be that P0, P4 segment right there, right? So we need to compute that one. And the way we compute it is, let's assume that that's the vertex angle right there. That's the border width, right? And the way we compute this radial difference, QP, is we draw a perpendicular from there to the edge of the outer polygon right there in that point R, and we're going to have an right triangle. So RPQ is going to be a right triangle with a right angle at R, and RP over QP is going to be the sine of this angle, which we know because it's half the vertex angle, and we also know this border width, so we can get QP, this radial difference. So it's going to be RP over the sine of that angle, and that angle is going to be half the vertex angle, which we can compute in the following manner. So we start from the fact that all the angles in a triangle always add up to 180 degrees, regardless of what those angles are. And then we can split every convex polygon with n vertices. We can split it into n minus 2 triangles. So here we have it for a hexagon, we have 4 triangles. And it's the exact same thing for a pentagon, we can split it into 3 triangles. Now the sum of angles in a triangle is 180, and this means that the sum of angles in an n polygon, which we can split into n minus 2 triangles, is going to be n minus 2 times 180. Now if all these angles are equal, so if we have a regular polygon like we have here, then just one polygon angle is going to be the sum of all angles in the polygon divided by the number of vertices of the polygon. So that's going to be n minus 2 times 180 divided by n. So that's going to be our vertex angle. N minus 2 times 180 degrees divided by n, and our radial difference, as we said earlier, is going to be that border width over sine of half that vertex angle. Okay, now knowing this, in the case of the inner point list, the radius is going to be 50% minus that radial difference. No? Okay, so the current angle in this case is going to be also the offset angle, but we go in the different direction, in the opposite direction, so it's going to be minus I times the base angle. Okay, and the inner list of points is going to be its previous version, and then we're going to have, again, the coordinates of the center along the x-axis in this case, and then we're going to have 50% minus the radial difference. So we're going to need to interpolate this, and we're going to need a calc because we are mixing units. So calc, and then again we're going to take this part, this cosine, right, and multiply this radius with it. Of course we need to interpolate again, and then pretty much the same thing for the y direction, except we're going to use sine right there, and here we're going to add the inner list of points, and this gives us a hollow hexagon. Okay, great, let's collapse this, and we're going to need to distribute stuff in 3D. But before we do that, we're going to need to add a few things right here. So we're going to want to pass to the CSS the number of arms, the number of hexagons per arm. So in a style attribute, we'll be setting so it's going to be like this. Okay, and the same for the number of hexagons per arm. Okay, now having done this, we are also going to have a style element right here and a loop. So for let I going from 0 all the way up to the number of arms, increment this I, and at every step we're going to have hex nth of type, and we're not using the nth child because style is a sibling of the hex elements and is before them, and it messes up with nth child. So here we're going to have n plus all the hexagons on the previous arms, so the number of hexagons times the current arm index plus 1, and it's plus 1 because nth of type index is 1 based as opposed to the loop index, which is 0 based. And here we're going to set the arm index as a custom property, so, and its value is going to be the loop index. Now having done this, we're going to copy paste and adjust it. Yeah, that should have been arm right there. Okay, so here we're going to have every number of hexagons, so like this. Okay, this is going to be the hexagon index on the arm. So here we'll be pre-computing like an arm progress kind of thing. So we're going to have calc the arm index over the total number of arms. So like this, and then we'll be computing a rotation around the x-axis, which is going to be that progress I times, and here you can see that we only go around half a circle, so let's use half a turn instead of a full turn, right? So then we'll have here transform rotate x, so use that. Okay, we're starting to see something, and let's say that we can have translate, let's say 10 ems. Okay, it's starting to look like something. Let's also add perspective 25 ems, something like that. Okay, you can see how it's getting better. Actually, let's add a minus that so you can bring it back a bit. Okay, looks better this way. And we're going to want to have another rotation around the y-axis. So for that, now one thing to note is that those hexagons at the ends, they're at the very poles. So that means that one is going to be at progress 0, the other one is going to be at progress 1. But the first index is going, the first hex index is going to be 0, while the last one is going to be the number of hexagons minus 1. So when we compute the progress, so calc the current hex index on the arm over the number of hexagons, this is not going to, the maximum that this can be is going to be smaller than 1. So we're going to divide by the total number of hexagons minus 1. So this can be at least 0 and at most 1. So then we're going to have calc, and this is going to be times half a turn or 180 degrees, same thing. Okay, so let's say that here we're going to have rotate y like this, and of course we want to have minus 90 degrees, so it goes okay like this. That's good. Okay, now let's also set backgrounds that are different for the arms. So we're going to have an HSL value. This one is going to be calc for the hue, and we're going to have I, the arm progress, times 360. And let's say that we're going to have 75 for the saturation and 65 for the luminosity. And let's also set a black background there, and I think we can collapse the body. Okay, it's starting to look better. Something else I want to do is make this angle also depend on the hexagon index on the arm. So let's say that here we're also going to have something like this. Okay, so it's starting to look nicer, and we're going to want to reverse those hexagons because you can see they're always facing us, so we're going to want to reverse those rotations. So that's going to be rotate y, right, minus 1, so we're going to have a calc. So something like this. Okay, and actually we can take this and use the calc here. And use the direct rotation here. So it's going to look something like this. And one more thing we can set here is mixed blend mode screen. Okay, so you can see the poles right there. It's looking interesting. We're going to see in a bit more. Now next we're going to want to add a rotation progress. So we're going to want to have a P here. And this is going to fall back to 0. And actually let's use one turn right there, and we're going to divide these by 2 or multiply with 0.5. So something like this. Have a space there because we need to have spaces around that. Okay, and we're going to register that. So property P. So syntax number. This is basically the type. Initial value. This is going to be 0. Inherits, not necessary, so false. Let's collapse this, and we're going to have an animation. So keyframes P and 2. So something like this, and here we're going to have animation P, let's say 8 seconds. Linear infinite, let's see it. Okay, it's starting to look like something. Yeah, we can increase these values. So for example, let's say 12 and let's say 20. Now you can see this looks pretty weird like this because we don't respect the distances anymore. So let's say that we're going to have we're going to pass a tangent value to the CSS. So let's compute that. The tangent. So this is going to be so half of the angle, which is so basically the full angle would be 2 pi over the number of hexagons per arm, but half of it is going to be the 2 and the 2 go, and we're going to want to limit the number of decimals. So let's say 3. Okay, so now we set the tangent here. Okay, so something like that. And having done this, we are going to compute a sphere radius. And calc 2 times, oh, it's not a custom property, it's, yeah, I just set it like that, over that tangent. Let's see it now. Okay, still a bit, oh, I'm not even using it, but I think we can increase it. So, and here we're going to have calc -1. So something like this. Let's see it. Okay, let's make this smaller. 1.5. 125, something like that. Okay, I'm going to leave it at this. I'm not going to be tweaking it any further. I hope you've enjoyed this video, and if you like the work that I'm putting out since early 2012 and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon, or if monthly support is not your style, there's the option of a one-time donation, or you can make me happy with a gift of my wish list. The links for everything for my Patreon, one-time donation, and my Amazon wishlist are going to be in the description, as well as a link to this finished demo and a link to all the resources mentioned here. Or you could at least share this to show the world what can be done with CSS these days, because honestly, I think it's pretty damn cool. In any event, thanks for watching, and until next time, bye!